Okay, so we have just introduced and seen examples of what a system of linear equation is. Now, we can, in principle, just grind through solving a system of linear equations by adding multiples of one equation to other equations and find the solution if it exists that way. But when a mathematician is posed a new problem, well, there's two questions that they ask that are not answered by what we've done. One, does the solution exist? Is there at least one solution? This is generally called the existence of a solution. We saw examples where there were no solutions, where there were multiple solutions, and where there was exactly one solution. So, assuming at least one exists, is there exactly one? Mathematicians refer to this as the uniqueness question of solutions. Is there exactly one solution? So, just to review some of the cases, case A, consider the system x plus y is equal to 1, and x plus y is equal to 2. So, what does this look like? You have your y and you have your x-axis, and when x is 0, y is either 1, 2, and in the one case, when y is 0, then x is 1, and so have something like that for x plus y equals 1, and x plus y is equal to 2, but y is 0, so y is 0, then x must be 2, and we have a parallel equation, and the solution to both of them will lie whenever they intersect each other, which is to say, never. There is no value of x and y which satisfy both equations. So that's an example of no solution. For infinitely many solutions, we could just consider x plus y is equal to 1. Then you have something that looks like this. Y and the x-axis, where any point on this line satisfies that equation. And since we don't have any information beyond that, then we have infinitely many solutions, all living on that line. And the third situation happens when you have like x plus y is equal to 1, and x minus y is equal to, minus 1. So you have our favorite friend, x plus y is equal to 1, and it looks like that. Now, when x minus y is equal to minus 1, when y is 0, x has to be minus 1. When x is 0, y has to be 1, right? 0 minus y is equal to minus 1. That's true when y is 1. So that means that x minus y equals minus 1 looks like this. Aha! So there is a unique solution here, namely x is 0 and y is 1. So there's a unique solution. There's infinitely many solutions in the previous case. And in the first case, there was sadly no solution. So how do we know which case we're in? Well, we could just grind it out and see how many solutions there are, but that's really unpleasant. So what we do is, well, we cheat and we invent new math. So remember when we talked about a system of linear equations? It looked like this. That was our discussion. We had a bunch of linear equations, and this is just a mess to look at. So instead, what we'd prefer is if it ended up looking like this, because this is simple. You just have to divide both sides by a, and I like that because there's none of this. I have to do n operations for one equation. It's just a simple divide and done. So if we could get this system of equations to look like just one linear equation, we'd be onto something. So what do we do to do that? And that is simple. We just generalize what we mean by a number. That's right, we invent something that looks like a number, acts like a number, but is not a number. Instead, it's able to encode this system as if it were a single linear equation like this. And that's what we're going to do with matrices. So that's exactly what we're going to do in this next act, as it were.